made mainly of actin protein molecules, organized into repeating segments called sarcomeres. The ability of skeletal muscle to contract relies on the structure of these muscle fibers and the surrounding nerves. When a nerve impulse reaches a motor neuron, a chemical message passes into the fiber of the muscle, and the thick and the thin filaments of the sarcomere slide across each other to shorten the muscle, creating a contraction. Smooth muscle lines the gastrointestinal tract, respiratory tract, blood vessels of the circulatory system, urinary tract, and reproductive organs. Smooth muscle tissue is in the walls of hollow organs throughout the body. The tissue contracts and relaxes to contain substances and move substances through the body. Smooth muscle contractions are involuntary actions managed by impulses that travel through the autonomic nervous system to the smooth muscle tissue. The arrangement of cells in smooth muscle tissue provides for contraction and relaxation with great elasticity. The smooth muscle in the digestive tract contracts and relaxes in peristaltic waves that move swallowed food and nutrients from the mouth through the stomach and the intestines. Artery walls include smooth muscle that relaxes and contracts as pressure changes, move changing volumes of blood through the vessel. The smooth muscle of the blood and uterus allow for great elasticity and contraction of those organs. Smooth muscle contracts in peristaltic waves that push food down the esophagus, through the stomach, into the small intestines, then the large intestine. The stomach wall is made up of 3 smooth muscle layers that contract to churn food. The oblique muscle layer of the stomach is an extra layer not found in the rest of the alimentary canal. Longitudinal layer, circular layer, oblique layer. The trachea and the bronchi of the respiratory system are lined with smooth muscles. The trachea and bronchi or bronchioles. Walls of arteries, capillaries, and veins contain varying amounts of smooth muscle. Artery, capillaries, vein, smooth muscle layers. Smooth muscle lines the ducts and organs of the urinary and reproductive system. Urinary organs, reproductive organs. Urinary organs, reproductive organs. Cardiac muscle, which is only found in the heart wall, contracts constantly to pump blood throughout the body. The heart wall is composed of 3 layers. A thin layer called the epicardium, which forms the outermost part of the heart wall. This layer adheres the heart to the pericardium, which is a double membrane which surrounds the heart, or a sac of tissue that protects the heart from friction as it beats. Beneath the epicardium lies a thick cardiac muscle of the myocardium. The myocardium is responsible for the heart's pumping action, making powerful, continuous contractions possible. This stretched tissue contracts involuntarily in response to signals from the heart's own conduction system. Beneath the cardium lies the endocardium, which forms the innermost layer of the heart wall. The endocardium lines the heart's internal structures, and it is continuous with the lining of the vessels that attach to the heart. Together, these three layers of the heart wall aid contraction and relaxation as the heart beats. The myocardium of the heart wall is made up of cardiac muscle that contracts in response to involuntary signals from the heart's conduction system. Movement of the skeleton often involves pairs of muscle that perform opposing actions like flexing and extending or bending and straightening. Muscles involved in these paired actions are categorized as agonists and antagonists. A muscle that contracts to generate the main force of an action is called the prime mover or the agonist for that action. Muscles that perform the paired and opposing action are called antagonists. The agonists in elbow flexion are the muscles that contract to bring the elbow joint into a flexed position. The antagonists are the muscles that perform the opposite action, elbow extension. When the action of elbow extension occurs, the roles switch. The triceps brachii is now the agonist and contracts to extend the limb, while the biceps brachii muscle is relaxed and becomes the antagonist. Muscles interactions throughout the body regions involve paired actions. These include flexion and extension, elevation and depression, pronation and supination. Skeletal muscles are attached to the skeleton by tendons. The areas where the tendons attach the muscles to two articulating bones are called the origin and insertion points. When a muscle contracts, the belly or middle part of the muscle shortens and moves one bone towards the other. Usually, the muscle's insertion point is on the movable bone, while the origin point is on the fixed bone. In elbow flexion, the biceps brachii pulls the radius upward towards the humerus. The motion of lifting the chain uses the first-class lever system. A first-class lever works like a seesaw with the fulcrum in the middle and the load and effort on the opposite sides. When the neck muscle contracts, they pull the back of the skull downwards and pull that side of the seesaw down, causing the load on the opposite side, the front of the skull, to lift upwards. The motion of standing up on tiptoe uses a second-class lever system. Second-class lever works like lifting a wheelbarrow with the fulcrum, the wheels on one end, the effort lifting upwards on the opposite end, and the load in the center. When the calf muscles contract, they pull upwards and move the weight of the body onto the ball of the foot. The motion of lifting the hand and flexing the elbow uses third-class lever system. A third-class lever system works like a fishing rod with the fulcrum at one end, the load at the opposite end, and the effort in the middle. When the biceps contract, they pull the bones of the forearm upward. The forearm bones pivot on the elbow joint and pull the hand upwards. Synovial joints are characterized by the presence of an articular capsule between the two joint bones, often supported by surrounding ligaments. Bone surfaces at a synovial joint are protected by a coating of articular cartilage. So it consists of an elbow ligament, articulating bones, and articular capsule. As the body moves, the vertebrae of the spine move against each other as gliding joints. Hinge joints, like the elbow, move on just one axis. These joints allow for flexion and extension. At the top of the spine, the atlas and axis form the pivot joint that allows for rotation of the head. The wrist joint is a condyloid joint that allows for circular motion, flexion, and extension. In the hand, the thumb's saddle joint let the thumb cross over the palm, making it opposable. The ball and socket joint found in the shoulder is a freely moving joint that can rotate on any axis.